Okay, so my name's Hannah Horsch, and I'm going to go over the DCE practice problems just to see if that might help you. I got these from Professor Hamilton, so I've got my calculator ready. So the first problem says the recommended dose of an antibiotic is 80 milligrams per kilogram per day. If the patient weighs 39 kilograms, how many milligrams per day should your patient receive? So first, we have 80 milligrams per kilogram per day. Patient weighs 39 kilograms. How many milligrams per day do you want to end up with? All right. So first, I always start with the order. So the order is 80 milligrams. And then when you have kilograms per day, those are going to be on the bottom. So kilograms per day times. So kilograms on the bottom, and your kilograms going to go on top over on here. So 39 kilograms for one patient times oh, I don't need that. Getting ahead of myself. So that would be 80 times 39 equals 3,120 milligrams per day. So we ended up with milligrams per day, and that's what we wanted to end up with. The patient weighs 44 pounds. The doctor ordered ampicillin 100 milligrams per kilogram per day. Ampicillin is to be given PO 4 times a day. Calculate the milligrams per dose. So this is 4 times a day, but we want to end up with milligrams per dose. So that will affect our answer. So we're going to start out with our order: 100 milligrams per kilogram per day times, we have a patient that's 44 pounds. So 44 pounds for one patient. And then we need to convert that into kilograms. So we have kilograms on the bottom over here. So 1 kilogram equals 2.2 pounds. And that equals 100 times 44 divided by 2.2, which equals 2,000 milligrams, because we have the kilograms and the pounds cancel out, so we're left with milligrams per day. But we need to know 4 times a day, and we're asking for 1 dose. So we need to divide that by 4, which gives us 500 milligrams per dose. The order of amikacin reads 2.5 milligrams per kilogram per dose, IV every 8 hours. Calculate the milligram per dose for a newborn who weighs 7 pounds, 4 ounces. All right. So we're going to start with our order, which is 2.5 milligrams per kilogram. So 2.5 milligrams per kilogram times 1 kilogram equals 2.2 pounds. And then, so 7 pounds, 4 ounces is, there's 16 ounces in a pound. So that would be 0.25, right? Why am I blanking on it? Yeah, that's 0.25. So 7.25 pounds for one patient. And that is 2.5 times 7.25 divided by 2.2 equals 8.23. So that would round to 8.2. Our next one, the order for aminophylline 45 milligram IV every 4 hours to be given to a patient who weighs 51.8 kilograms. How many milligrams is this patient receiving per day? So we're going to end up with receiving per day. And our order is 45 milligrams IV every 4 hours. So we're going to start out with 45 milligrams over 1 dose. And it looks like the 51 kilograms is actually extra information we don't need. So they're going to get it every 4 hours. So that would be 6 times a day. And that's 270 milligrams per day. Ordered is Hydrea 30 milligrams per kilogram per day. The patient weighs 157 pounds. How many grams per day is the patient receiving? So we're going to start off with the order. So 30 milligrams per kilogram per day times 157 pounds for 1 patient. And then we need to convert that to kilograms. So 2.2 pounds, 1 kilogram. And then our pounds cancel out, our kilograms cancel out, and we're left with milligrams per day. Oh, but look, we have to do grams per day. So we need 1,000 milligrams on the bottom, since our milligrams is on the top over here, is 1 gram. So our milligrams cancel out, and we're left with 30 times 157 divided by 2.2 divided by 1,000. And we're left with 2.1 grams per day. This one's a little complicated. So our order is 1,000 milliliters and 20 milliequivalents potassium chloride every 8 hours. Available is 1,000 milliliters solution bag and 40 milliequivalency in a 20 milliliters of potassium chloride. The IV is set with a drop factor of 15 drops per milliliter. How many milliliters of potassium chloride would you withdraw and inject into the IV bag? So our order is 20 milliequivalents for 1 dose. And we have available 40 milliequivalents in 20 milliliters. So for that, we're going to do 20 times 20 divided by 40. I think it's that. 20 times 20 divided by 40 is 10 milliliters, because our milliequivalents cancel out. And then the second part is, how many drops per minute should the IV be set? So we're going to start with the order is 1,000 milliliters every 8 hours. So we're going to do 1,000 milliliters over 8 hours times 15 drops per milliliter And we want to know per minute, so we need to convert our hours to minutes. So 1 hour is 60 minutes. Our milliliters cross out, our hours cancel, and we're left with 1,000 times 15 divided by 8 divided by 60. And we're left with 31.25, but you can't have a partial drop. So that's going to go to 32 drops per minute. The patient is to receive 1,000 milliliters an hour of D5RL IV. Available micro drip set of 60 drops per milliliter. How many drops per minute should the patient receive? So we're going to start with our order, which is 100 milliliters per hour. 100 milliliters per hour. And then we need to convert our hours to minutes to get our answer. So 1 hour is 60 minutes times our drop rate, which is, since milliliters over here on the top, we're going to put it on the bottom. So 1 milliliter is 60 drops. So 100 times 60 divided by 60 equals 100. 100 drops per minute. Oh, can y'all see that? Okay. An IV with 10,000 units of heparin in 500 milliliters is infusing at 20 drops per minute using a 20 drop per minute infusion set. Calculate the units per hour. So we're going to start with our order, which is 10,000 units of heparin in a 500 milliliter solution. So 10,000 units in 500 milliliters. And then 1 milliliter in 20 drops. Because the milliliters are on the bottom, we're putting them on top over here. And then we've got 20 drops per minute. And then this is per hour, so we need to convert our minutes to hours. All right, so we have our milliliters cancel out, our drops cancel out, our minutes cancel out. We're left with units per hour, which is where we want to end up. So 10,000 times 20 times 60 divided by 500 divided by 20 equals 1,200 units per hour. The patient is to receive 500 milliliters of RLIV over 6 hours. What is the drip rate of drops per minute if the tubing provides 12 drops per milliliter? All right, so we have 500 milliliters over 6 hours. So that's our order. 500 milliliters over 6 hours. We need to convert our hours to minutes. So 1 hour is 60 minutes. And then our tubing is 1 milliliter per 12 drops. So we do 500 times 12 divided by 6 divided by 60, and we get 16.66, which rounds to 17 drops per minute. The patient is to receive 40 milligrams of a drug in 50 milliliters of normal saline over 1/2 hour. What is the drip rate if the tubing provides 15 drops per milliliter? All right. So we have 40 milligrams of a drug and 50 milliliters of normal saline over 1/2 hour. So let's see, how do we set this up? So we have 50 milliliters over 30 minutes. And then our drip rate is 15 drops per milliliter. And we want to end up with drops per minute. So our milliliters cancel out and we're left with drops per minute. So 50 times 15 divided by 30 equals 25 drops per minute. Calculate the total volume in milliliters the patient has for your 12-hour shift. So there's 2 apple juices, so that's 16, a 24, an 8. So 16 plus 24 plus 8 equals 48. And you're going to times that by 30. So times 30. So that's 1,440. And then an IV of 75 milliliters per hour. So there's 12 hours. So 75 times 12 equals 900. So 900 plus 1440 equals 2,340 milliliters. The recommended dose of an antibiotic is 80 milligrams per kilogram per day. If a patient weighs 39 kilograms, how many milligrams per day should the patient receive? So we're going to end up with milligrams per day, and we start out with 80 milligrams per kilogram per day. So 80 milligrams per kilogram per day times 39 kilograms for one patient. So we're going to do 80 times 39 equals 3,120 milligrams per day, because our kilograms cancel out. Penicillin, 25 milligrams by mouth every 8 hours. Patient weight is 45 pounds. Safe dose is 50 milligrams per kilogram per day. How many milligrams per day will the patient receive? So we want milligrams per day. And we have 25 milligrams every 8 hours. So we're going to start with, let me put that down a little bit so y'all can see. 25 milligrams over 8 hours. And there are 24 hours a day for one day. So our hours, and we're left with milligrams per day. So 25 times 24 divided by 8 equals 75. 75 milligrams per day. And the safe dose is 50. So no, this is not safe because it's subtherapeutic. No, it's above therapeutic. we got to calculate the milligrams and kilograms. Okay, so we're going to start with 50 milligrams per kilogram per day. And 45 pounds is one patient. And then we need to convert the pounds to kilograms, so 2.2 pounds is 1 kilogram. So kilograms cancel out, or pounds cancel out, and we're left with milligrams per day. So 50 times 45 divided by 2.2 equals 1,022 milligrams per day is the safe dose. So it's actually way under. So it's still not safe because it is subtherapeutic, because it needs to be 1,000 milligrams a day, basically. All right. So for these, we're just gonna do a quick conversion. Rounding, I mean. So this one rounds to 24.6 milliliters, 24.3 milliliters. This one is to 20, it rounds up, right? So 29 drops per minute, 32 drops per minute, 29 drops per minute, 268 micrograms, because this 5 bumps the 9 into a 10, which bumps that up into an 8. And again here, so 157 milligrams, 1 gram, 0.9 milliliters, 250.3 milligrams, 10.3 kilograms, and this one is a 0, so that doesn't round at all, so it's 15.9 pounds. Okay, I hope that helped you.